Good afternoon, everyone. My name is Randall Cutro, and I'm the Senior Solutions Engineer for Quovim. And today I'm going to be talking about why the cloud and getting ready for the cloud. Why are we going there? Why are we there? And why does I've got about 25 years experience in IT, about 20 in contact center and about 16 or 17 working with Interactive/Genesis. So I like to tell people I grew up in the contact center world. All right, moving right along. So why is it time to move to the cloud is what the topic discussing. And in order to understand the whys, you need to kind of understand the history. What's interesting is the development or the migration to the cloud is really my history. It is my history and how my career has evolved. And I'll talk about that and relate to how my experiences has actually mimicked what's happened with the cloud. So the drive to e-commerce. Well, when I first started working in contact centers, many contact centers had server rooms that were full of servers that would serve out the applications required by the agents to handle calls. So there's CRM, maybe their ticketing environments, and also the phone system that would handle the automated call solution for the contact center. And then as e-commerce started to become more and more prevalent around the turn of the millennium, we saw more companies starting to build their e-commerce solution. And what that entailed was building web servers that could provide an e-commerce experience for the customer. And so businesses started growing those e-commerce environments in their data centers. But the problem with that is those data centers weren't really designed to grow as quickly as e-commerce demanded, and also as the whole e-commerce business started to grow, we saw businesses outgrowing their offices, outgrowing their data centers, and so something had to give. At the same time, we had telcos developing technologies that allowed customers to connect to remote data centers using private WAN technologies. The most prevalent would be MPLS and Layer 2. So MPLS being a protocol that allowed us to connect to many different sites and build a private cloud that connected all those sites. So you could have a data center that had all of your technology in it. You could have your main office that had all your business people. You could have another office that was your contact center, and they could all be connected together using MPLS technology. Layer 2 was much more direct, so it was a point-to-point technology. But the point of the matter is these technologies allowed businesses to take their data centers and move them off-site, which allowed them to grow dynamically. They could secure the data centers, and they could build stronger and much more powerful e-commerce environments. And of course, I just mentioned it, but the concept of colocation came into view, where businesses would take their data centers that were located on site, and they would buy a slice of space in a colocation facility. These colocation facilities were designed with backup power, backup access to the internet, as well as great access to services like MPLS and Layer 2, so that customers could come in and buy a slice of that space, host their technology there, and connect to it with those technologies I just spoke about. What eventually happened, though, is the amount of servers required and the amount of space to host those servers became daunting. So along came the virtualization technology, where servers had become so powerful, rather than having a physical server hosting one virtual server environment, we could host several virtual server environments on one physical server. That made the footprint required inside of a data center shrink, and it allowed customers to build much more powerful e-commerce environments and grow what they were offering to their customers in their e-commerce environments. So because these data centers became so much more important to the customer, well, then they started thinking about, well, if I lose my data center, what happens? So then we started looking at replicating data centers. So we would have two. And one would back up the other. systems would be replicated across those data centers. So if one data center was lost, the other one would continue going. Often this was done, maybe one in North America, one in South America, maybe one on the East Coast, one on the West Coast. In North America, that's often how we do it. In Europe, it could be in different countries or on different continents. But geo-redundancy really allowed businesses to ensure business continuity during major disasters that areas where data centers are hosted could experience. And then we had the Great Recession. And this was a very interesting time for myself. At the time, I was working for a company called Register.com, very large contact center here where I live in Yarmouth, Nova Scotia. There was 350 outbound seats. We had 100 inbound seats. And we were a .com hosted out of New York. So it was a very, very big business, and the recession hit. And just like all of these other e-commerce, of course, Register.com does domain register. They're a domain registrar, so they are key to e-commerce. But a lot of these other businesses started looking at all of the equipment that they had purchased, all the capex expenditures that they had put in place to support the e-commerce, and then facing after the Great Recession 50% or more reduction in the amount of business that they were getting from customers. So that left them in a really bad spot where they had invested a lot of money in capex and were forced to depreciate that capital expenditure without having the revenue to support the infrastructure they had built. And that was a big problem with the Great Recession, because as businesses retooled to kind of deal with the shrink that came after the Great Recession, because there just wasn't as much money around, they found themselves with all this technology they didn't know what to do with. And they also couldn't just throw it away. They had to depreciate it. And so you saw C-level management talking a lot more of, okay, we need to get away from capital expenditure and more OpEx style solutions. And this is where cloud computing started to be discussed. Okay, rather than having us hosting our own applications, what if we were to purchase an application or rent an application as a service? What if the application was sitting on the internet and we just bought a slice of that and hosted what we needed inside of that cloud computing environment? So the concept of a SaaS started to be discussed. So, solution as a service, where rather than building a complex server room or a data center to host your e-commerce or your solutions that you needed to support your customer, you simply went out and found someone that could build your e-commerce environment that could host it as a service. The advantages to that is, well, if your business grows, you simply pay a little bit more and they provide more resources to support your e-commerce environment. If you shrink, then you pay a little bit less. You don't need as much licensing or whatever the model is. And the provider of the SaaS simply shrinks the amount of resources available for your e-commerce environment. And so then we saw the march towards the cloud. And this was an interesting time for me. I mean, one of my biggest backgrounds is Active Directory and Exchange. And I can remember when Office 365 came out, and I looked at it and went, there's no way that a lot of businesses are going to move towards moving their Exchange environments into the cloud or their Active Directory environments. These are key to their businesses. But that's exactly what happened. And boy, was I wrong. So we saw a lot of early adopters, Microsoft with Azure. So what Microsoft did was they took the exact same infrastructure they used to support their Office 365 and Azure AD offering, and then they started building a application hosting environment called Azure that you could buy a slice from. So you could go and you could host a microservice, you could buy a hosted server where you could put your own code on, or you could have your code hosted. It really depended on what you wanted to do. Amazon Web Services did the same thing. At the time, they were a major retailer. They had made it through the Great Recession. And the way they did that was they had an amazing e-commerce environment that they had built themselves, and they had built it in such a way that it could deal with the Great Recession and the whole capex to opex march. And so they started selling slices of that to potential customers, businesses that wanted to host their e-commerce environments. And so we saw Amazon Web Services taking off as an early adapter. the key to both of Amazon Web Services and Microsoft Azure, these big players, the key is a concept called the elastic dynamic load balancers. And what that really means is that these platforms, what they do is they monitor the required resources necessary to support the environment that you're hosting and dynamically add or subtract resources necessary to support that environment at any given time. So what you need to imagine is there's a pool of resources, and each customer coming in AWS or in Microsoft Azure is drawing from that pool, and the amount of horsepower to support your environment is dynamically added or subtracted based on the requirement. This is key because this really allows us to move into an OpEx world without worrying that we're going to run out of resources to support the customers we need or invest too much in infrastructure to support growth that later we experience shrinkage, and then all of a sudden we're left with infrastructure that we don't necessarily need. Microservices became very popular. So rather than you hosting, maybe getting a web server or a server built inside of these environments, maybe you just needed the application like a DNS service or an e-commerce environment or whatever. So then we saw microservices, basically these little tiny services that are required to provide an e-commerce environment were presented themselves as a service rather than the infrastructure to support them. And then the idea of the cloud-based contact center became more and more prevalent. If you think about it, the contact center world is really, even though traditionally we've had to focus a lot on CapEx expenditure to build contact center environments, the business model really lends itself towards being more OpEx. And when we moved away from contact centers simply being call centers, where people were contacting us via SMS, or contacting us via email, chat, and now social media. Well, locating our contact center solution in the cloud allowed us to be much closer to all the other tools that we need in order to provide that experience. For example, I'll talk a little bit about Genesis Cloud in a minute, but one of the products that we sell and support every day, Genesis Cloud, because it lives in the cloud, it can easily integrate into CRMs to pull and push data. It can easily integrate into artificial intelligence, which Peter will talk about later. Moving it into the cloud brought it one step closer to having access to all the resources required to provide that seamless single pane of glass experience that the agent required to effectively handle the customer. So how did this happen? Well, first of all, we saw the internet becoming far stronger. So one of the biggest issues with moving a contact center into the cloud is you need to start moving voice across the internet. And traditionally, we protected voice across WANs and LANs, so customer data networks, by using something called QoS, by giving priority to the voice. So literally, in a customer LAN or a WAN, so an MPLS layer 2 or their local data network, we would deploy QoS, which would move the voice traffic first and everything else second. But across the internet, you can't do that because you can't give, the internet doesn't support QoS. And the reason why it doesn't is because, well, how can you say your traffic is more important than anybody else's? It's a public network. So the internet itself started to become much more resilient. We saw this starting to really take hold about 10 years ago, 11 years ago, when things like two-way FaceTime videos started to become more prevalent. I mean, FaceTime, Skype, all these different services, and they started in the consumer world, and that's where they became stronger and stronger, where they became good enough where we could start using them in the contact center space. We also started migrating the applications that we use in the contact center to cloud, to web-based apps. So, for example, the applications that supervisors and managers use, the applications that the agents use to handle the call. Everybody's heard of the soft phone, the software-based phone, but then there's a concept of the web-based phone that became developed. So you had a phone that was basically accessible through a browser. And in order to tie this all together and to ensure we had the best experience possible, like I said, we had the WebRTC phone, which was a web-based phone, browser-based phone, so there's no software install or anything. And layered on top of that is the Opus codec. So what is Opus? Opus is a really interesting codec. Traditionally, when we move voice across data networks, we usually use G711, which is no compression at all, or G729, which is there's quite a bit of compression there, but it's static compression, meaning that the compression is set and it doesn't change. Well, what Opus did was Opus dynamically compresses the audio signal based on the quality of the network connection. And the best way I can explain this is if you're speaking to someone overseas from, HP or Microsoft or someone like that, and you're speaking to them and it sounds like they're kind of hollow and far away, but you can still understand what they're saying and there's no packet loss, well, that's Opus at play. And every once in a while, maybe their voice gets a little bit clearer and then it goes farther away again. That's Opus making sure that it doesn't drop any packets, so it adds compression to make sure the call can still happen. Opus is used a lot to move calls over long distances across the internet now, and it is key to ensuring that we can have clear and concise conversations in a contact center world with agents working from home or in the office using cloud-based contact center solutions. So where we are today, well, where we are today is the march towards the cloud. We're seeing a lot of contact center solutions now moving into the cloud. In fact, that's what we sell and support ourselves. We're seeing a lot of integration into a lot of other technologies that are available on the internet to provide a better experience. I talked about that earlier. And one of the hottest topics, which my friend Peter is going to talk about in just a second, is going to be the whole artificial intelligence piece, which is really providing as close as we can a human experience for our customers, but doing it with machines instead of people. And why are we doing that? Well, I mean, what Peter will talk about will kind of allude to that. But at the end of the day, we're faced with the amount of interactions that contact centers are facing. It's actually going up. We're looking at different media types. It's increasing. And so therefore, contact centers are having a harder time finding enough agents to answer all those interactions. So we have to come up with creative ways in order to allow machines to answer customers whenever possible. And artificial intelligence is a way to do that. And of course, those that were early adopters of contact center solutions in the cloud, they were very successful at sending their agents home during COVID. So, now those that haven't been early adopters to cloud-based contact center solutions have really suffered during COVID because, of course, they couldn't have their agents working from home, or they had to scramble to put technology in place. Those that were on those technologies simply sent their agents home, and a lot of times with nothing more than a headset. As long as they had an internet connection at home and some type of a PC environment at home, they were ready to work and to deal with working from home. That's pretty much it. Any questions?